Having a system like the Entity API in Drupal makes it so that we can write code that's really generic and will work in all kinds of different situations with all different types of entities. This does provide some problems though. It can be hard to query for and get a list of all of the entities when you don't even know what all of the different entity types are. That's why we use a class in Drupal 7 called Entity Field Query in order to build queries to list entities. Rather than querying the database directly, we'll use the Entity Field Query class to build up lists of conditions to query against entities' properties and fields. We do this because in Drupal, we don't necessarily always know what the underlying SQL structure is going to be like, and that could change really quickly. For example, someone could install a new module and check a couple of boxes and click Save, and in the background, Drupal's rewritten the structure of some of our tables. And this can cause problems when we're trying to list things. So let's take a look at using Entity Field Query in order to build lists of entities. My favorite documentation about using the Entity Field Query class is at this page on Drupal.org, How to Use Entity Field Query in the Documentation Handbook, or drupal.org/node/1343708. It contains a list of most of the things that you can do using the Entity Field Query class, including querying for conditions, properties, fields, sort ordering, and so forth, with some pretty good examples of how to do those things. It also contains links to some additional articles down here at the bottom, which point you at more information. I highly recommend these two articles, Let Drupal Do the Heavy Lifting Part 1 and Part 2, from the treehouseagency.com site, which do a really good job of explaining some of the concepts of Entity Field Query even further. Let's take a look at using the Entity Field Query module in our own code. Back in our demonstration module, I've added a new menu path at demo/1, which calls a page callback function, entity demo 2, from the file includes entity demo demo2.inc. In this file, I'm going to implement our function here, our page callback, and I'm just going to return a simple string. That way, over on our site, we'll actually have something to look at. The first thing that I want to do is just build a simple query using the Entity Field Query class that gets a list of all entities in our system that are of the type node. So I'm going to create a query object that is new Entity Field Query, and then I'm going to use the entity condition method of our new Entity Field Query object. The entity condition method takes two arguments. The first is the property that you would like to query. I'm going to query for entity type, and the value that you would like to query for. It also optionally takes a third argument, which is the operator that you would like to use for this query, but we'll come back to that. Entity conditions are used for querying properties that exist on all entity types. An example of that is the entity type itself. So nodes, users, files, they all have an entity type. They all have unique IDs. They all have version IDs, and most of them have bundles. Those are the things that you can query for a value of using the entity condition method. And then I'm going to execute my query by calling the execute method and assign the returned results to a variable named result. And I'll print that out on the page. And this is all I need to do in order to build a simple list of all of the node entities on our system. Let's go back and refresh our page. And you can see up at the top, I've got my output. If I tip that open, what I see is an array containing the value of keys node, and inside of that is an array of all of the node objects on our site. Looks like we've got 62 of them. And then if I take a look at any of these returned results, I'll see the ID, the version ID, and the type for that node. The Entity Field Query module doesn't actually load and return the entire entity itself. It just returns a stub entity. It's just giving me the information that I need in order to load this entity completely. So we saw in the previous lesson, I can now take this, the NID or node ID, and the type, and pass that to the entity underscore load function in order to load that node in its entirety. I'm also currently only querying it for entities that are of the type node, but they're all grouped together under this node key. That's because it's possible that entity field query could return entities of multiple different types. If, for example, I queried for a property that existed on all of those, or a value that existed on both nodes and users, I might have a mix of users and nodes in my results here. We'll definitely see that as well. Let's create another query. I'm going to just create a whole new query object. And this time what I'd like to do is I'd like to query for the value of a field. So this is already a little bit different. Fields, if you remember, can be applied to bundles of any entity type. So now I'm querying for a value that could exist on one or more entity types. Use the field condition method to query for fields using entity field query. The field condition method takes 4 possible arguments. You need to tell it the name of the field number. You need to tell it the column in the database or whatever storage mechanism you're using for that field that you'd like to query against, and a value, and finally an operator. So this is saying query the value column for all fields named field number to see if they have a value that is greater than 100. If we switch over to our site again real quick, and we navigate to the structure tab, content types, and we look at our article content type, you can see we've got this additional field underscore number field attached to the article bundle. So I'm querying for values on that field. I've also got that field attached to our user entities. So you can see same field applied to a different bundle. When I use entity field query here, I'm expecting to get results from both of those node types. The other thing we mentioned is that this column, or this argument here, the second argument, refers to the column that you want to query for a value. Figuring out what argument to use here can be a little bit tricky. Different field types can have multiple columns in the database. Images, for example, store a file ID, the alternate text, the title text, possibly some other information as well. The table in the database that stores all of that information has multiple columns in it. You need to specify which of those you're querying against. If we open up our MySQL tool and take a look at the table, we can see how this works. When our field was created, it created a couple of tables in Drupal's database. I'm just going to search for all tables that contain the string field number. That's the name of our field. And we've got this table here, the field data field underscore number. And if I look at the structure of that table, I can see it's got a handful of columns. The first ones here, all of these relate to how this field is attached to a particular bundle and an instance. And then there's some that contain a value. All of the value fields will always start with the name of our field, so field underscore number, and then underscore value. Value here, that actual string, is how I knew what to use in my field condition. So as another example, our image field that came with Drupal core is named field underscore image. When using the entity queries field condition method with an image field, I could substitute in place of the string value, I could substitute FID if I wanted to search for a particular file ID. I could use title, alt, width, or height are all possible values or columns that I could query against using entity field query. Remember that you need to remove the part that is the field name, field underscore image underscore, and only insert the actual column name into the field condition. So that's how I knew here that I could enter in value as the second argument for our field condition. The operator here is going to depend a little bit on the type of value that you're querying for. In this case, I'm querying for numbers, so it makes sense that I can use an operator like greater than or less than or greater than or equal to or even equal to. If I was querying for a string, the operators that are available are things like or contains or is equal to. All of this is documented on the documentation for the field condition method for entity field query. I'm going to execute this query and we'll print out the results of this one so we can see how that happened. So back on our site, if I navigate back to our demonstration page, I've just rerun the page, executed that query. I've now got two elements here. That's because this query returned nodes of two different types, or entities of two different types. Nodes and users. Same thing though, it's returned stub entities. UID is all I need to know in order to load a user. Node ID, which has bundles, I need to know the name of the bundle, article, and the actual unique ID of the node in order to load that. Both of these though, I could use with the entity_load function in order to load the object in its entirety. Let's take a look at another example. I'm going to create another query here just to keep the demonstration going. So I'll copy this first line, create a new query object. This time we're going to query for a property using the property condition method. This works almost identically to the entity condition method, and then I need to specify a property name and a value to query for, and optionally some operator. So I could do something like the condition is promote and the value is 1. And this maps to the promote property on node entities. Or let's take a look at the database again. If I look at the node table, specifically, I'm querying against this column in the node table, promote. Using property conditions is different than the other two though, because properties are entity type specific. Promote, for example, exists on the node entity type, but it doesn't exist on the user entity type. So in order for this to work, I also need to specify an entity condition. If I didn't, the entity field query would throw an exception and not even try to execute my query here. So I'm going to add a entity type condition so that it knows I only want to deal with nodes which happen to have a promote property. Once that's in place, I can execute my query just like before and print out the results. Take a look at that. And we see output that looks just like before. An array of entity types. Within that array, I get all of the stub entities for that type. So you can use entity field query in a lot of different ways. We've seen a couple of examples here, using entity conditions to query for properties that are common across all entity types, using the field condition to query for the value of a specific field regardless of what entity type it's attached to, and querying for entity-specific properties using the property condition method. You'll also note here that this is evidence that you can chain multiple conditions together into a single query to narrow down the results even further. We could, for example, even add this field condition to our already created query, and now we've got entities that are of the type node that are promoted and have a field number value that is greater to 100. In addition to methods that allow us to narrow down the results of our query, we've also got methods that will allow us to do things like change the order in which those results are returned. I could add a field order by condition here. So I've added a field order by condition. I have to specify the field name and value, or the column here, and this works just like it did with field condition. And then I can specify an ordering direction, ascending or descending. So this will return are all entities of the type node that are promoted that have a field number value that's greater than 100, and it will return them in reverse order of the field number value. In addition to field ordered by, there are also equivalent methods for entity conditions and ordering by properties as well. I recommend you take a look at those as they're super helpful. So now that I've got all these nodes being returned from entity field query, how do I go about loading that information from the database? How do I get the entire node so I can deal with it like I'm used to? Well, our result here, if you'll remember, is an array that is an array of stub entities ordered by type. And so one option would be, if I knew that this is only returning nodes, I could do something like this. I know that this query is only ever going to return entities of the type node. I've specified that in the condition right here. In order to extract all of the node IDs, I can use the array keys function from PHP. And then I can use the entity load function that we saw in the previous lesson, pass in an array of all the IDs of the entities that I'd like to load, and it'll load those for me here. Let's take a look at that. So now we've got 24 nodes returned, and it's actually loading the entire node object instead of just the stub nodes that we saw before. And that's because we're able to use entity field query to query for entities of any type, and then based on the information that we know about these entities, we can use the entity load function to load the complete object. If I didn't know specifically that these were all entities of the type node, I could figure out their type because the returned result was keyed by entity type, and I could figure out their IDs using the entity extract IDs function, also from the previous lesson. There's a handful of other things that you can do with entity field query, like adding pagers, just like you would with a database query, so that you return a maximum of 10 results and then a pager to page through them. You can also specify a range. So I could do query range to limit this to return only 10 entities. Again, I recommend you take a look at the rest of the documentation for entity field query, and that going forward, you make use of it anytime you're trying to build lists of entities, since it's generic and will work independent of whatever's going on in the background in your database with Drupal.